All right, what do we think about this first reading question? This kid says choice 4. What? You're smiling. He says choice 2. All right, we got a 4 and we got a 2. Victor? Okay. Well, it says which one will result in the perimeter being different? So, what is it going to be an isometric transformation? Like a translation, rotation, reflection? Will it be one of those? What one must it be? A dilation. Well, which one of those is a dilation? You know, like with a scale factor, K. What is it?
30.
You guys agree? What is 4? You guys, what is 4? If you just add 2 to the x and subtract 5 from the y, what is that? Come on, you remember what that is.
That's correct.
The translation. You guys should listen to this kid more often.
Yeah, I know.
It just, you remember that? It moves 2 to the right and 5 down. It's isometric, right?
That's fine.
So this is the dilation. Okay. Number 2, I'd recommend making a sketch of that probably. Okay? Read that over. So it's a square. We know about squares, don't we? And we got RS is 9. There's a couple ways you can do this, I guess. What do we think new perimeter will be? Thomas? 108. How did you come to that conclusion, Mr. Einstein?
Oh, now I can.
Don't know that. Ask your comments.
9 centimeters, scale factor 3. 3 centimeters.
Okay, so he multiplied the sides all by 3, right? So he did 3 times 9 equals 27. So that's the side of the new square. And then you did what? And you got 108. Can I ask you this? Could you have found the original perimeter first and then multiplied that by 4? Or 3? What do they do?
Yeah.
Oh, by 3, yeah.
4.
Right. Because scale factor also applies directly to perimeter, doesn't it? So we could have also, let's just see. So if we did, the original perimeter was 4 times 9, we'll just say or here. Which equals what?
36.
And there's 4 sides of 36, so the new perimeter prime, would be 4 times 36, which is what? Or no?
3 times.
Wait, what did I do? Oh, wait. Oh, I'm doing the scale factor, yeah. I was mixing that one up. 3, yes, sorry. 3 times 36. What's wrong with my pen? Which is also 108, right? Either way. Moving along. Number 3. Yeah, okay, scale factor, new over old. That's kind of why I did use that and not the words pre-image and image, because I know sometimes that can get confusing, new over old. So, new what over old what? What did you use exactly?
C and C prime.
Okay, so you work with C and C prime. Okay, and what new and what old did you use? So it's centered at the origin, so that makes it kind of simple, right? Okay, so go ahead.
I use their x and y values. I like both of their x values and their y values.
And tell me exactly what you did with them. So you
I
just
did-
work with C prime. Go ahead.
I did 9 divided by 6.
Mhm.
And negative 6 divided by negative 4.
Okay, so K equals new over old, right? Now, So that, remember, any new linear measurement, right? Including rise or including run, right? Are you with me on that? Okay. So since it's centered at the origin, isn't the rise and run just the coordinates here? So the 6 would be the run, original run, right? The old run. And the -4 would be the old rise, right? Because it would be, 6 minus 0, right, in the slope formula. And C prime, what's the new run in C prime? 9. What's the new rise? So do you have to do them both? Right, so let's just do, so 6 would be the old run, right? And 9 would be the what? The new run, right? Because that's the x value. The run measures this way. With me on that? Guys with me? And k equals new over old. Did you even have to bother with the -6 and -4? Right? Any one of them, right? Any single corresponding, they have to be corresponding linear distance, right? Like you can't do, the new rise divided by the old run. You got that? So let's just do the run over run, right? So k would be new run is what? 9. Old one was what? 6, which equals reduces to 3/2. Would that have worked? Let me ask you this. Check it with D and D prime. What would be the new run over the old run for D and D prime? 3/2. Same answer, right? What would, for D and D prime, what would be the new rise over the old rise? -12 over -8, which reduces to what? 3 positive 3/2 again, right? Any corresponding linear measurements, new over old, get you k. Okay? And again, so now if it wasn't centered at the origin, it'd be a little more complicated, right? You'd have to actually do the subtraction. Does that make sense? Okay. And what else we got? We got a couple more here. Let's move along. Now this one here, I want you to do it with the complicated way. Because I have one like this on the test, right? So I want you to do it kind of like the homework you did last night, where it was the center x plus, what's the scale factor? Half the run, comma, center y. But what are the x and y in this one? Or what are the centers x and y in this one?
0, 0.
Yeah, because it says, right, the origin. So that we're going to use 0, 0, right? So I kind of want to say 0 plus, right, that times that, comma, 0 plus that times that. Follow me? So you're going to have to. Now, here's. Okay, I'll give you a second to read it over, and then I'll tell you what I see as an error very often. So read that over, get it in your head. So here's what I find is a real common mistake. A lot of kids, when they go to find, like, they should be finding the original rise and run, we want to get the rise and run between the center and the point, not between the 2 points. So this is a little different than your homework, right? You got 2 points. A lot of kids will do the slope formula on A and B, right? That's not what we're looking at, is it? We need the slope between what and A? 0, 0. And it looks like we have to do it a second time for B, aren't we? So we'll need the slope between what and B? Separately, right? So it's like on the homework, except you got 2 points to do that too. That makes sense? Okay? So get the original rise and run for A and do it, okay? And leave B out. Like when you're working with A, you're just working with A and the origin. and leave B out of it for now. And then go do the same thing for B and leave A out of it. Right? Because we're not worried about the slope between A and B. Just the slope between each of them and the center 0, 0. Okay? I mean, normally this would just be a simple kx comma ky and do it twice. But again, I want you to do it because on the test, pretty sure it's going to be the center other than 0, 0. Okay? So give me a minute. Put these in the grid so as we go through it, it'll help make it clear. So A is at 2, 3. 1, 2, 1, 2, 3. B is at 1, 2, 3, 4, 5, 1. So here's A. Oops. Here's B. All right, we got that. So really, so that's 0, 0, right? The origin, that's an O. You know what? I'm going to do this differently. So kind of look at, say I put in the dilation paths from the origin, right? A is going to move along this path here, okay? A is moving along this path and B is moving along that path. So we're not worried about the slope from A to B. Does anybody have the coordinates for A prime?
1 and 3 halves.
1 comma 3 halves or 1 comma 1.5. Anybody else get that? How about B?
I got 5 halves and negative 1 half.
All right, 2.5. So I would say, yeah, normally I like to keep things in terms of fraction, however it is, right? But remember, if you're going to try and plot that in the coordinate plane, it's probably appropriate to put it, because what are you going to count? 5, right 5 halves, right? So might as well use 2.5. In that case, would be appropriate. Anybody else get that? Uh-oh. Perhaps we should go to the video. You did?
I'm wrong.
What?
I got 2.5.
2.5 and what?
Yeah.
Should be negative 1 half.
Or yes, I
So you were right. You mean you were wrong?
don't want them.
Okay. So you were right. B, for B prime anyway. Well, maybe we should look at it, huh? So let's just work with A first of all. Remember, we're not doing anything between A and B. So first we need the original rise and run, right? For A, from the origin to A. So I'll write it this way. Like the slope is rise over run, right? So I'll do the slope M of OA, right? I'm doing the slope of this segment here, OA, the original rise and run from O to A. Everybody with me? And remember, we have to do A stuff minus O stuff in this case. Follow me? So we need the original slope, and we can apply the scale factor to it. So that would be what minus what over what minus what for OA?
3 minus 0 over 2 minus 0.
3 minus 0 over 2 minus 0. Remember, I'm overcooking this here, right? Because on the test, it's not going to be 0, 0, okay? So these zeros will be replaced with whatever the coordinate of the new center are on the test. You got me? Okay? So that gives us 3 over 2. So that's our original rise and our original run. Okay? So originally, to get to A, right, it was 0 plus what? Guys? To get to A, it was 0 plus what for the run? 2. And to get to A for the rise, it was 0 plus what?
3.
3. What are we going to do to that plus 3, or plus 2 and plus 3.
Multiplied by a half.
The scale factor is going to be half of that, isn't it? Right? Okay. So instead of 0 plus 2, right? So for A prime, it's going to be 0 plus the original run of 2. Not 2, but what? Plus half of that original run of 2. Follow me? Comma, for the rise side, 0 plus not 3, but what? Half of 3. Are you following? Right? We're just doing mathematically what you did in the plane, you know? You would have counted the, okay, just that homework yesterday. Where instead of counting over 2, you used half, so you did a run of 1, right? So let's just simplify this. Half of 2 is 1. 0 plus 1 is what? 1. Half of 3 is what? 1.5. 0 plus 1.5 is? Okay. So there's A prime. Right? Do the very same thing for B prime now, all you guys. Okay? We'll see if you can get it right. Well, let's get the original rise and run for B prime. So I'll do now the slope of O to B originally is what minus what over what minus what? Negative 1 minus 0 over 5 minus 0, which simplifies to negative 1 over 5, right? So this is that rise, its original rise in this original run, okay? But what are we going to, so it was 0 plus 5 to get to B, right? And then 0 minus 1 to get to it, right? But now it's going to be half of those, isn't it? So B prime will now equal 0 plus, instead of 5, it's what? Half of 5, just like you were counting in the plane, comma, 0 plus, instead of negative 1, it was what? Half of negative 1. What's half of 5? What's 0 plus 2.5? Second half to what? There's 2 points, yeah. What? Second, sometimes I don't know. What's half of negative 1? Negative 0.5. What's 0? So negative 0.5. Does that clear things up a little bit with that? I don't think it's as complicated as you think, right? As long as if you picture what you did when you counted the grid, you're just doing it mathematically. Yeah. I think it's quite a bit, actually. There's a lot going on there. Good. So yeah, I wouldn't leave it blank for sure.
Might get the jackpot on this one.
Yeah, I understand it. It's just a big stupid error.
No,
So the next one. Triangle. You're going to do some stuff. There's a few things they need you to do to it, okay? And I would say on this one, it's centered at the origin, right? So to expedite this, you can just do the simple kx comma ky to get all the 3 primes, okay? So first thing I would do is write down the coordinates of q and then r and then s. And then you get your q prime by kx ky, r prime kx ky, right? All right, take a minute. I'll go ahead and start writing down my coordinates for q, r, and s. So q, whoops. Q, I have it. 2, comma 2. I'll leave a little space because I can do q prime. And then r is at 2, comma 0. S is at 4, comma 6. And like in between here, maybe I'll do q prime, r prime, and s prime. And unlike the one we just did, right, centered at the origin, so you can use the simple kx, ky, right? Gives you the points, okay? Bottom. So it'll be 3 halves times -2, comma, ky. 3 halves times 2. I have to go into the plane here. What's 3 halves times -2? Yeah, the 2's cancel, right? So you got -3, comma.
Do you have to do that with the equation or can we just put the?
It's just kx, ky. This is because it's centered at the origin. I know that last problem centered at the origin, but I wanted you to do it more complicated because, you know, once you be ready for the test.
If this were a lot of work, -3, yeah.
I got to see kx, I got to see the work. Yeah, right. Come on, man. Kx, comma, ky. It's simple, right? Yes, right. But that's why you're here. Right? And then r prime would be k times 2, comma, 3 halves times 0, right? Which is 3, comma, 0. Whoops, I'm messing up here. So S prime here would be 3 halves times 4, comma, 3 halves times 6. Uh-oh, this is a little more complicated. What's 4 divided by 2?
6.
4 divided by 2 times 3. Oh, wait, what's 4 times 3
Well, wait.
divided by 2? Hang on a minute, Trenton. So 6, comma, what's 6 divided by 2? Times 3. 9. Trenton, question.
You have -3, 2, but keep going. It's -3,
Oh, yes, thank you. All right, so then we just go ahead and plot it here. So the Q prime is a -1, 2, 3, 1, 2, 3. And then 1, 2, 3, 0. And then we got 6, 9. 6, I guess that's because they're all 10. All right, it's 10 by. And don't forget this. You will lose points for this. Not doing this, I should say, right? Does ones look like that then? Right? Okay. So let's go to the second part now. And we want to read this carefully, right? Kids answer this in different ways, but there's really only one way to answer it because they tell you specifically how. Specifically, how do we answer this? By what? Using slopes. You know what the slope formula is, right? Change in y over what? I want everyone else to say it. I know you know it. Slope is change in what over change in what? How do you get to change in two numbers? Subtract them. That's where the y symbols y1 raised to minus x1 comes, right? Okay. So to use slopes to explain why. Oh wait. So hey, listen. If two lines are parallel, what can you say about their slopes? Huh? Well, numbers we don't say congruent. They're remember equal, right? If their slopes are equal, then the lines are parallel. So it looks like we got to find the slope of what? And QR, right? Did you do that yet?
Yeah.
Did you? Do it. All right. Well, you guys said I'm going to give them a minute to do it. Okay. Let's do the slope of QR. So you'd be slope is m, right? So m subscript QR, right? Equals something over something, right? And then you'll do the m of q segment q prime r prime, little subscript, right? Equals something over something over something, right? Okay? And then you'll explain. We get negative 1/2 for one of them? Whoa, we mean, oh. Okay, well, yeah. The other one would be, let's see, 0 minus 3, and the coordinates are over 3 minus negative 3, right? So that's negative 3 over 6, which reduces to, hey, what? Everybody get negative 1/2 for both of them? I shouldn't have to copy that down. The slope formula from kindergarten.
I don't know. I got 3 over.
You got what?
3 over.
3/2 for which one?
All.
Okay. Look at the coordinates. So take Q and R. What are the coordinates of Q? Negative 2, and R is 2, 0, right? 0 minus 2, y2 minus y1, over x2, 2, minus negative 2, just 2 plus 2, right? Similarly for the other ones. So if you got negative 1/2, now we have to explain. What's the explanation? Why are they parallel? Yes.
Segment QR is below segment Q prime or prime because corresponding slopes are
Well, we know the corresponding slopes are, and slopes are numerical, so we'd say equal, right? Or you can say they both have a slope of negative 1/2, so they're parallel, right? Something like that. But you got to find that they have the slope of negative 1/2. So they both have a slope of negative 1/2. So let's write what they write. Q prime R prime parallel to QR. Okay? With me on that? So they said use slopes to explain. So you have to find the slopes, get them simplified and reduced, and then you can compare them directly and explain. Any questions on this one? All right, then. One more to go. Moving along. Last one. Read that over. Thomas, what's the transformation? That's a dilation, but we need some more information, don't we? What other information do we need? We need the center and what?
the center point and the chair point.
And the scale factor. Well, the center, probably pretty clear to find, right? It's what?
A.
So it's a dilation centered at A, and we need to know what the scale factor is. Hey, the K. How do I find K, guys? 1 over what? Come on. Any new linear measurement divided by its corresponding old linear measurement. It's kind of all sitting diagonal of plane, right? So you can't really count any of the side lengths, so what could you use? What other linear measurements do we have available? Rises and runs, right? Okay. So what's the scale factor? So don't forget K equals any new linear measurement over the old, new over old. Right? So find K. If you just start at A, and I don't know, compare, the run from C to the run all the way out to E, right? Does that make sense? Did you do that? So let's just compare the runs. All right, we pick any linear measurement. So what's this original run here, the old run, from A to C? 4. And then what is it from A to its corresponding point E? 12. So 12 is the new, 4 is the old, right? So K equals 12 over 4, which is 3. Did you use 12 and 4, or would you use something different? What did you look at? We now know the center. We now know the scale factor. So we could write it in a notation, right? Couldn't we, if we wanted to? I could say it'd be a dilation, what?
Center today.
A, comma, what?
3.
3 of triangle, what is it? ABC. It's triangle ABC. ABC maps to triangle A what? It's at top. A, couldn't see it. ADE. Or, could we write it out in words if we like?
Yeah.
Yeah, sure, either one. So like if you're not sure you're going to get the note, because if you get the notation a little bit wrong, you know, you lose points. So if you're not comfortable with that, hang on. So give me a second. So we could just say a dilation with center A and can't write today. And scale factor of 3, something like that.